Hi, today we're going to be learning about the distributive property. Our I can statement for the day is I can use the distributive property to simplify algebraic expressions. Our vocabulary for today is, of course, distributive property, term, constant, coefficient, and like terms. A term is something that would look like x or x plus 3. Terms that are alike can be combined, and that's what you see here on this vocabulary term. So a like term would be something like x plus x or 5y squared plus 5y squared. Those terms then would be alike. A constant is just a number. A coefficient is a number that we see in front of a variable. So for example, if our variable was the letter V, then the coefficient would be the number in front of the variable V. We know that as the coefficient. You're going to hear us talk about coefficient a lot of times in algebra this year. To simplify the expression, we use the distributive property. The distributive property means to multiply the number that is on the outside of the parentheses by the numbers that are inside of the parentheses. The first thing you want to do before you talk about distributing a term from the outside is to ask yourself the simple question, is there anything inside of the parentheses that I can combine? In other words, on example number 1, can I combine the n with the negative 3? The answer to that question, of course, is no. I cannot combine n and negative 3 because those terms are not alike. So if I can't then combine the terms, the next step is to distribute the 3, which is outside of the parentheses. I like to use an arrow to remind myself to multiply the 3 by the n and by the negative 3. So we have 3 times n, which is 3n. And then, of course, we have 3 times, remember, this is a negative 3. So we look at that as one term, 3 and negative 3, a positive times a negative. When the signs are different, that's always going to be a negative. So our final answer then is 3n minus 9. In the next example, we have negative 6 times the quantity t minus 6. The first thing that I would do is look at the parentheses and look inside, and I see that I have a t, and I see that I have a negative 6. If I can combine those, I want to go ahead and combine them. But in this case, just like in example 1, we cannot. So we know that we need to distribute the negative 6 to t and distribute the negative 6 to negative 6. So we have negative 6 times t, or negative 6t. Notice that I'm being very careful with my t. I want to make that look like a t, not a plus sign. And then now I have a negative 6 times a negative 6. A negative times a negative is a positive 36. So my final answer, negative 6t plus 36. In my next example, number 3, I want to continue and always ask myself that question. If there's something that I can combine inside of the parentheses, then I want to do that first. So I noticed right away that I have a 7q. I'm just going to use a box around my 7q. And also, I have a negative 19q. Notice that I did include the negative with the 19q. In addition, inside the parentheses, I have a plus 8. I'll use a circle this time to represent my constants, and I have a negative 12. So those can also be combined. So what I'm going to do then is just bring down the 0.25 that's outside of the parentheses, and I want to combine 7q minus 19q. That's going to give me a negative 12q. And then I have a positive 8 and a negative 12. That's going to give me a negative 4. From here, there isn't anything else that I can combine within the parentheses. Now it's time to go ahead and distribute the 0.25. So I can think of that kind of like a quarter, like 0.25, that's 1/4. So 1/4 of 12 is 3. I know a positive times a negative is going to give me a negative 3Q. Of course, you can feel free to use your calculator. Let me see if my calculator will pull up and I will punch that in for you. Doesn't look like that's going to cooperate. So you can go ahead and just punch that in your calculator. I'll give you time to do that. 0.25 times negative 12 equals negative 3Q. And then now I have 0.25 times negative 4, which is going to give me then 1, negative 1. Now, if you're wondering, what if I forgot to combine my like terms within my parentheses and instead I just distributed the 0.25 to each term, would you in fact get the same answer? And the answer to that question is yes, you would. If you did it the other way, I'll show you what to do with that. You can see in that case, then I went ahead and distributed each time. So now at this point, I would have to combine my terms, my Q terms. And then I would combine the constants of a positive 2 and a negative 3. And so as you can see, then either way, you're going to get exactly the same answer. I don't know about you, but I like it a little bit better the first method. I like to combine my terms and then distribute, but really, again, it's just a matter of preference. On example number 4, we cannot combine 4W and positive 16 within the parentheses, but I can distribute 1/4 to both terms. 1/4 of 4 is just 1 whole. And as you know, I could write 1W, but that simplifies down to W. 1/4 times 16, or 16 divided by 4, is going to give me a positive 4. Feel free to use your calculator anytime you need to. You can use the ABC key, 1, ABC 4, and that will automatically put that into your calculator. Just, using the ABC key is how you're going to put a fraction into your calculator, in case you didn't know that part. The last two examples, instead of distributing or using the distributive property, we're going to be combining like terms. So let's talk about what to do with that. On number 5, if this was just combining like terms, let's use a problem that's a little bit easier, something maybe that you've seen in the past. Let's just use 2s and 4s. If I was going to combine those, I would say, yes, of course I can combine those, because that's like 2 sand dollars and 4 sand dollars. I could combine those together, which would give me 6 sand dollars. Well, it's exactly the same thing when you use a higher exponent. We're going to say 2s cubed and then a positive 4s cubed. That then is going to give me, we're going to combine our coefficients. 2 plus 4 is 6, and then s cubed, final answer. So this one we'll just say is an extra example, just to remind us how to combine like terms. Moving on, number 6. In this example, you will see several different types of terms. I see some m's, I see some z's, I see a constant. So once again, I like to just use a symbol of some kind, circle, rectangle, triangle, a cloud. I'm going to use a cloud this time just to kind of mix it up a little bit. And I'm going to go ahead and cloud 8m squared, and then I see another m squared term. What you want to make sure you do here is to include the negative in front of the m squared. And another thing to remember, anytime I do not see a number in front of a variable, we know that that number is a 1. So in this case, it's a -1. I also have a -5mz and a +4mz. And then last but not least, I have a constant of a 4, so I'll just use a circle for the +4. So to combine the m squares, we already know that the number in front of the m is a 1, so 8 minus 1 gives me a 7m squared. And then -5mz, I can combine those because both of those terms have an m and a z. So -5 plus 4mz is going to give me a -mz. There is no need to include the 1. I know that -5 plus 4 is -1, but you do not have to include that. In fact, it's not really simplified if you put the 1 in front of it. And then last but not least, the constant. Notice the order that I listed these terms in. We call that standard form or descending order. So you'll see that I included the m squared and then m and z, which both have an exponent of 1, and then your constant. So that really is the best form in which to leave your final answer. That does it for distributive property and combining like terms.